Okay, let's continue talking about the techniques of differentiation. And this particular section we will devote it to implicit differentiation. Basically, implicit differentiation is a process of finding derivative of implicit function. A typical implicit function look like this: x squared plus y squared minus 2y equals to 50. Alright, this is a typical implicit function. And basically, any implicit function, it's very difficult to express y in terms of x, almost impossible, right? That's why we call that implicit function. Alright, so the objectives, we'll learn how to distinguish between functions written in implicit form and explicit form. And we will learn how to use implicit differentiation to find the derivative of the implicit function. Okay. So first of all, let's learn how to distinguish between the implicit functions and explicit functions. So most functions have been expressed in explicit form, meaning you just express y in terms of x. Okay, so the variable y is explicitly written as a function of x. Okay, so that's the definition of an explicit function. And some function, however, are only implied by equation. For instance, the function y equals 1 over x is defined implicitly by equation xy equals 1. Okay. Suppose you were asked to find dy of dx, meaning find the derivative for this equation. You could begin by rewriting y explicitly as a function of x, and then differentiating using the power rule. Okay, let me just remind you the power rule. N times x, n minus 1. Okay. Implicit form, x times y equals 1. And then you convert the explicit form, y equals 1 over x. Then you turn it into exponents x to negative 1. After that, you apply the power rule to find the derivative. The strategy works whenever you can solve for a function explicitly. However, you may not be able to express the function explicitly all the time. So in this case, we have to use a different procedure to find the derivative. You just look at this. This is what we call implicit function. So it's almost impossible to express y in terms of x. So then we have to do implicit differentiation. And this is a technique devoted to find a derivative for implicit function. In order to find dy over dx or derivative implicitly, you must realize that differentiation is taking place with respect to x. That means whenever you differentiate terms involving x alone, you can differentiate as usual. However, when you differentiate terms involving y, you have to apply the chain rule, because you are assuming that y is defined implicitly as a differentiable function of x. So you always multiply by y prime element. Okay. So let's take a look at different differentiating different component of implicit function. First of all, if you look at x cube, we can apply the power rule, then you get the answer right away. So it's put exponent 3 in the front and reduce power by 2, that becomes 3x squared. And when you differentiate x, actually it's 1, right? So you times 1 still remain the same. However, when you differentiate y cube, now you first of all you apply the power rule, then you have to differentiate inner function. Okay, inner function is y, so you end up with y prime. So, and most of the time people just write 3y squared times y prime. It probably looks slightly easier, right? Anytime, just remember when you differentiate y, always multiply by y prime at the end. Okay, so for now I will use y prime instead of using dy over dx, because I think that is a lot easier to do. Okay, and let's take a look at x plus 3y in order to differentiate that. So x, derivative of x becomes 1. Derivative of y becomes 1. And we have to differentiate inner function y prime. So we end up with 1 plus 3y prime. Okay. Okay, so how about differentiate x times y squared? So we gotta use the product rule, right? So here, this is f, that's g. So f equals to x, f prime is 1, right? G equals to y squared, g prime. Derivative of y squared becomes 2y times y prime. Okay, so the answer should be written as d dx f times g. So we have a prime of g plus f g prime. F prime is 1 times g, which is y squared, plus f is x times g prime, which is 2y times y prime. So we get a y squared plus 2xy times y prime. So if you want to write 2xy times dy over dx, they are equal, right? So these two are exactly the same. But I feel like y prime probably is slightly easier to carry on. So now next, let's move on to the technique of implicit differentiation used to find the derivative of implicit function. Guideline for implicit differentiation. First step, differentiate both sides of the equation with respect to x. Second step, collect all terms involving dy over dx on the left side of the equation and move all other terms to the right hand side of the. This is what we're talking about, y prime, right? Same thing as y prime. So isolate y prime. On the left. Then factor y prime, okay, out of the left side of the equation and solve y prime. dy of dx. Okay, so let's take a look at this particular implicit function. So now let's use the implicit differentiation technique to solve it. We'll find derivative given that y cubed plus y squared minus 5y minus x squared equals -4. So we know that for y cubed, we apply the chain rule, right? So it's 3y squared times y prime. For y squared, we get a 2y times y prime. Notice that every time when you differentiate any term with respect to y, you always multiply by y prime. That's a key thing to do. And derivative of y is 1. And remember to multiply y prime. And derivative of x squared is 2x. Derivative of -4 with respect to 0 with respect to x is actually 0. Alright, so now get rid of 2x on the left hand side. So adding 2x from both sides of the equation. So now we have 3y squared times y prime plus 2y times y prime minus 5y prime. And that is equals to 2x because we cancel that. Okay, so then next step is factor out y prime. So we have 3y squared plus 2y minus 5 equals 2x. Now very last step, dividing both sides of the equation by 3y squared plus 2y minus 5. 3y squared plus 2y minus 5. And then cancel that. Now y prime equals to 2x over 3y squared plus 2y minus 5. And if you want to write it as dy over dx, feel free to do so. But I feel like if you write dy over dx in replacing y prime, it's too much work. Right? So 2x over 3y squared plus 2y minus 5. Okay. So that's either answer will look definitely good. Okay. And you can also take a look at alright, so let's move on. So let's take a look at the application of the implicit differentiation. This is a typical implicit function, graph of implicit function. The graph looks very unusual, right? I would say. From the graph, you can see that y is not a function of x. Even so, derivative finding in example 2 give us a formula for the slope of tangent line at a point on its graph. The slope at several points on the graph are shown below the graph. So 2, 0, you just basically gotta replace this is x equals 2, y equals 0 into our implicit differentiation, into the derivative, right? Which is this. And when you plug in 2 and 0 into the derivative, then you come up with the slope. Okay. So this one, x equals to 1, y equals to 3, come out the slope. X equals 0, come out the slope. X equals 1, and y equals 1, and come out the slope. And then notice that when both x and y are 1, then the denominator is 0, so the slope is undefined. That means it's a vertical line, right? Here, it's a vertical line. Vertical tangent line. Okay. One more right here. So this is the vertical tangent line. Undefined slope. And this one is like 1/8. It's positive. It's 1/8, and this one is negative. Negative. Slope equals negative over 5. and this one slope equals to 1/8. Okay, so in order to find the slope, you just plug both x and y into the derivative, and whatever the number is, then that's going to be the slope of tangent line at that particular point. Okay, maybe let me just do one of this to show you the let me do first one, right? X equals 2, y equals 0. So we're gonna plug into this equation, this one. All right, so slope at tangent line at x equals to 2 equals to 2x over 3y squared plus 2y minus 5. Then replace x with 2, y with 0. So 2 times 2 over 3 times 0 squared plus 2 times 0 minus 5. So it's 4 over -5. That's why we have a -4 over 5. So that's how you find the slope of tangent line. And let's do a practice. Determine the slope of the graph 3 times parenthesis x squared plus y squared to the second power equals 100xy. At a point 3, 1, that means x equals 3, y equals to 1. Okay, so first of all, we got to find the implicit differentiation of the original function. Okay, so let's just write the equation first. On the second step, we start differentiating the left hand side. So we have we have to use the chain rule here. So exponent goes in front, x squared plus y squared, and then reduce the power by 1. And we're going to differentiate the inner function, meaning find the derivative of x squared plus y squared. Alright, then on the right hand side, we got to apply the product rule, right? And derivative of x is 1 times y plus x times derivative of y is 1, but you get to multiply by y prime anytime you differentiate y. Okay, left hand side 6 x squared plus y squared times derivative of x squared is 2x, derivative of y squared is 2y times y prime. So on the right hand side is 100 y plus x y prime. The next step, we just gotta carry out all the terms with y prime. So we can just distribute it. So we get a 6. Get an x squared times 2x, 2x cubed. X squared times 2y, y prime is 2x squared y, y prime. Plus y squared times 2x is 2x, y squared. Plus y squared times 2y, y prime is 2y cubed times y prime equals to 100 y plus 100 x y prime. Next step is still maybe distributed. We have a 12x cubed plus 12x squared y prime plus 2x squared plus 12. 6 times 2 is 12, right? 12 xy squared and plus 12 cube y prime 100y plus 100 xy prime. So now we gotta isolate all the variable terms, right? So We're gonna move this to the side, move this to the other side. So after you move it, you get 12x squared y prime plus 12y cubed y prime minus 100 xy prime equals 100y minus 12x cubed minus 12xy squared. Now factor out y prime. We get a 12x squared y plus 12y cubed minus 100x. On the right hand side, we're going to leave it like that. 100y minus 12x cubed minus 12xy squared. Then eventually you end up with y prime becomes this. We reduce everything by 4, right? And that's your derivative. Then the very last step, you just replace x with equals 3, y equals 1 into the derivative. And then you perform the operation, eventually end up with negative 65 over negative 45, and then reduce both top and bottom by negative 5. And becomes 13 over 9. And this particular graph is what they call Nanny's gate. Nanny's gate is a very special graph. And the slope of tangent line at 0.31 is 13 over 9. Okay. So that's pretty much it. You definitely should go over this example on your own. Implicit differentiation is it's not an easy topic. Usually it's very heavy algebra involved. So pay attention to this. Okay.